It's Mrs. Trombley again. Now it's time for lesson 2-4, and we're going to learn a different form of a linear equation. We're going to learn and discuss standard form today. So we'll start out kind of bringing it back to y equals mx plus b, and in the end you'll see standard form and when it is used the best. So first things first, because standard form has a lot to do with x and y intercepts, that's when you'd want to use this, when you're trying to identify the x and y intercepts easily. So just to review, finding the y-intercept of a line is the y-coordinate of the point where the line crosses the y-axis. It can be identified as the b in an equation written in slope-intercept form. And basically, it's the value of y when x is 0. So it's the value of y when x equals 0. X-intercept is opposite of that. This is the intercept, it's the x-coordinate of the point where the line crosses the x-axis. You can identify it from an equation by substituting 0 in for the y in solving for x. So it's the value of x when y is 0. So opposites. All right, and in taking a look at this graph, I know there aren't little dots on here, but this graph is made up of an infinite number of points on here. And we can see that this right here is where it would touch the y-axis. So that is your y-intercept, and that happens to be at 3. I'm going to say 0, 3. All right, and right here, this would be your x-intercept, and that one is 2, 0. So notice when you're finding the y-intercept, the x value is 0. You have to go 0 over to get to the y. And when you're finding an x-intercept, the y value is 0 because you don't go up or down to get to the x-axis. All right, so the first thing we're going to do, I'm going to give you some equations, and I want us to find the x and y intercepts given by each equation. You might be thinking, well, how on earth are we supposed to do that? I can find the y-intercept, but the x-intercept? Well, okay, let's work through these. I have y equals 5x minus 10 or plus negative 10. First off, you know that if an equation is written in y equals mx plus b form, we can identify the y-intercept right off the bat, right? And this one, the y-intercept, would be equal to negative 10, right? The b in the equation. Well, if I want to find my x-intercept, we said the x-intercept happens when y is 0. So basically what we want to do is we want to figure out when y is 0, what x is equal to, right? So to do that, all we need to do is plug 0 in for y and solve for x. So this is going to tell us when y is 0 what x is. So we really just have a nice little two-step equation here. 10 would equal 5x. We would divide by 5. And our x would equal 2. So our y-intercept would be negative 10. And our x-intercept would be a positive 2. And that would be another way to graph this if you wanted. You could plot the negative 10 on the y-axis, and you could plot 2 on the x-axis and connect them with a line. Right, and looking at b, again, this one's written in y equals mx plus b form. I know that the y is by itself on the other side, but that's okay. So I'm going to add the opposite here. And we can already see that our y-intercept is 4, right? That's the number that's by itself. If I want to know what the x-intercept is, then I have to know what's the value of x when y is 0. So now I would be solving 4 plus negative 12x equals 0. So we would have to add a negative 4 or subtract 4, whichever way you look at it. And then we would divide by negative 12 to get rid of that coefficient. And x would equal, well, 4/12 would simplify to 1/3, right? And if you have a negative divided by a negative, that means it's positive. So the x and y intercepts, it's okay to have a fraction, it's no big deal, would be 4 1/3. Let's try another one here. Okay, now this one, it's not written in standard form in slope-intercept form right off the bat. So instead of rearranging it, I'm going to have you look at this a little bit differently. We said that we find the x-intercept by plugging 0 in for y. To find the y-intercept, we could just plug 0 in for x if we wanted, right? So if you plugged in 0 for x, you'd have the opposite of 0, which is just 0. 0 doesn't have an opposite. And to solve that, you would add a negative 3, and we'd get y equals negative 3. Yes, you could have just added a -3 and done it that way as well, but I wanted you to kind of see the connection that, okay, I could plug in 0 for x to get the y-intercept too. So there's that. Now, I'm looking for the x-intercept. That means I want y to be 0, right? So 0 plus 3 would be -x. Now, you might think, well, we're done. It's 0 being added, and the x is by itself. X isn't. It has a negative sign in front of it. To get rid of that negative sign, you need to divide by -1, right? That -x means -1x. So I'm going to divide that by -1. I'm ignoring this 0 because it's nothing, right? So -1 divided by -1 is 1. X is alone. 3 divided by -1 is -3. Voila! And it's okay that they're the same. The y would be -3 on the y-axis. The x would be -3 on the x-axis, and you can connect them with a line. Alright, one last one here. I have 2y equals 6 minus 3. I'm thinking I meant to put an x there. It'll be on your paper later, don't worry. Okay, so if you want to, we can rearrange this and find the y-intercept that way. Or we could just plug in 0 for x to find the y-intercept. Why not? So 2y minus 6 equals 3 times 0. So 0 in for x gives me the y-intercept, right? 2y minus 6 equals 0. We can add our 6. 2y is 6, divide by 2, and the y-intercept of this would be 3. So there's 1. Now to find your x-intercept, I'm going to scooch it over a little bit here. The x-intercept happens when the y is 0, right? So 2 times 0 minus 6 would be 3x. I think I can fit this on here. Or just plain old -6 equals 3x. Divide by 3. And your x-intercept for this one would be -2. Alright, so I know that was a barrel of monkeys. It was pretty fun, right? I'm going to show you a little bit easier of a way to do this that's less time consuming. And I'm hoping that by doing all of that, you'll now come to appreciate standard form and not think, what, something else we have to memorize? Alright, so standard form. The standard form is ax plus by equals c. A and b can't both be 0. And this form of a linear equation makes it super duper easy to figure out the x and y intercepts. Alright, turn your page. So our goal, I want us to be able to graph equations in standard form. And we're actually going to use our x and y intercepts to do that. There are 2 options. I'll show you option number 1. I'm guessing you're going to prefer option number 2, but I'll show you option number 1. So again, your goal, I want you to graph that. We've already spent some time graphing equations written in y equals mx plus b form, right? Plot the b, do the rise over run for the slope, and call it a day. So this is just, if you first saw this before you knew about standard form, you would probably start rearranging this, right? You would add a -4x to get that y term by itself. So we'd have -3y equals 12 plus -4x. And then we would divide every term by our -3. And you'd get y equals -4 plus, and we like to leave our slope as a fraction because it's easier to graph. So I'm going to put 4 over 3x because that negative over another negative means that it's positive. So graphing that. And if you don't have a ruler, you might want to press pause and go grab one, or you can connect your dots after if you want, after the lesson's done, but don't forget to connect them. Alright, so -4 plus 4/3 x. My b in this is -4, so that means on the y-axis I would go down 1, 2, 3, 4. And if my slope is 4/3, that means it has a rise of 4 and a run of 3. And it doesn't look like I'll be able to fit another set on there, so I'm going to let you slide with just 2 points instead of 3, because I used a smaller graph here. So voila! We just graphed the line, right? We did a whole bunch of stuff, we figured it out, we're feeling good. Now, I'm going to show you the same exact equation, and in less steps, okay? So, you know that when you plug in 0 for y, you get your x-intercept. And when you plug in 0 for x, you get your y-intercept, right? Well, when you multiply 0 by something, you get 0. So if I was trying to find the y-intercept, I would plug in 0 for x, right? This is what I call the cover-up method. If I'm solving for the y-intercept, isn't 0 times 4 0? Right? So I would be left with negative 3y equals 12. And that means my y-intercept would be negative 4. Right? If I'm solving for my x-intercept, I would plug 0 in for the y. Well, 3 times 0 is 0, right? So I can just cover up the y term, and I'd be left with 4x equals 12. You divide by 4, and x is 3. So again, all we really did was we plugged in the 0 for the y and got the x-intercept, and we plugged in the 0 for the x and got the y-intercept. Now if I know the y-intercept is negative 4, I can put a dot at negative 4. And the x-intercept is 3, I can put a dot at 3 and draw my line. And hopefully you notice it's no different than the one above it. It's the same exact graph. It's just a little bit, I think, quicker of a way to identify it. So if the x and y intercepts are nice whole numbers, that's when this is a beautiful thing. So there are needs for y equals mx plus b, don't get me wrong, but in this kind of situation, ax plus by equals c is a lot faster. Alright, so let's try a few more. And we're just going to do the not rearranging way, we're going to do the x and y intercept way. Alright, so if I want to find the y-intercept, I'm going to cover up the x term. So if you cover up the x term, because you're really plugging in 0, you have 3y equals negative 6. If I want to know the x-intercept, I would plug 0 in for y, and that would go away, leaving me with negative 2x equals negative 6. Solve for both. My y-intercept is negative 2. My x-intercept is 3. Now, graph your y-intercept at negative 2, your x-intercept at 3, and draw your line. Nice, huh? Alright, yes, fractions, it's okay. Alright, for this one, if I want to know my y-intercept, I would plug 0 in for x, and negative 1/2 times 0 is 0. So you'd be left with 2y equals negative 2. To find my x-intercept, I would plug 0 in for y, which would make that go away because it would be 0. And you'd be left with negative 1/2 x equals negative 2. For the y, divide each side by negative 2. Your y-intercept is negative 1. For this, with my fractional coefficient, remember we multiply by the reciprocal. So we're going to multiply each side by a negative 2, because negative 2 over 1 times negative 1 over 2 gives you 1, and 1x is x. And negative 2 times negative 2 is 4. So plot your y-intercept, plot your x-intercept, connect the dots. Alright. Last one of these, and then we'll move on to writing equations, which is not too bad. I think you give story problems a bad rap. They get a bad rap sometimes, but they're not too bad if you know what to look for. Alright, if I'm trying to find my y-intercept, I'm going to cover up the x because it's 0. So the y-intercept would be 3y equals negative 3. To find my x-intercept, I plug in 0 for the y, so I'm just left with x equals negative 3. Well, that's nice. The x-intercept is all set. Help if I put the negative sign. So for y, just divide by 3. The y-intercept is negative 1. The x-intercept is negative 3. So there's my y. There's my x. Grab my ruler. And make my nice line. And voila. So I could have rearranged every single one of these and found the b and did rise over run to get from one point to the next. But just plugging in those zeros with these, I think made it go a lot faster. Alright, last page. Okay, I want you to be able to write an equation in standard form. And you have to recognize when you're supposed to write it in standard form, because it's not always given to you in a way that would reflect standard form. So, kind of going back to slope-intercept, you learn that when you write equations in slope-intercept form, you're given a constant, or starting amount, and one rate, right? And all you do is you take that constant, and that's your b, and you take your rate, and that's your m, and you plug it into y equals mx plus b. That's how you recognize slope-intercept form. You're going to be able to recognize when equations should be written standard form, because you're going to be given a total amount, and you're going to be given two rates instead. So when you're given an equation in y equals mx plus b form, you're given one rate and a starting point. When you're given something that should be written in standard form, you're going to have two rates and then a total. So I have kind of a mix of some problems here for us. It says, in a supermarket, each cup costs $4 and each bowl costs $6. If you want to spend exactly $34, write a linear equation modeling the situation. Let x represent the number of cups you buy and y represent the number of bowls that you buy. Alright, so it's $4 per cup and it's $6 per bowl, right? Isn't that 2 rates? And you want to spend exactly $34. That's a total. So here we go. Each cup, it's supposed to represent x. And it says each bowl, use y to represent the number of bowls. So cups would be 4 times the number of cups. And bowls would be 6 times the number of bowls. And I want that to equal 34. And we just wrote an equation in standard form. That was tricky. I know, you're probably exhausted, I bet. Alright, let's try another one. You have $32 total to spend. Each CD in the store costs $10 and each book costs $6. Write a linear equation modeling the situation. Let C represent the number of CDs and let B represent the number of books. So, each CD is 10, right? So it's 10 times the number of CDs. Each book is 6, so it's 6 times the number of books. And you want that total to come out to be $32. We didn't use X and Y. I didn't because I want you to see that you don't always have to use X and Y. This is still in that form of a number times something plus a number times something. We have a variable and a variable. So don't get stuck thinking it has to be X and Y. It can be any letters that you want. Although I don't recommend using O's or L's unless it's capital L, like this one, because they could be confused with numbers. Alright, last one here. A baby snake was 25 centimeters long when it was born. Each week it grows 2 centimeters. Write a linear equation modeling this situation. Let W represent the number of weeks that have passed and L represent the total length of the snake. Now I'm not trying to trick you with this because I did discuss what equations in slope-intercept form will give you when you're supposed to write them. You're not given 2 rates. You're given how long the snake was when it was born. That's your constant. That's a starting amount. It says that each week it grows 2 centimeters. That's your rate. So that would be your M. This would be your B. This wouldn't be appropriately written in standard form. This would be y equals mx plus b form because you're given 1 rate, and I'm supposed to use, I wasn't supposed to use x and y. I'll fix it in a minute. You're given 1 rate and 1 starting point. You're not given 2 rates. So I'm going to rewrite this with the letters that they say that they wanted. It says W represents the number of weeks, so I'm going to take 2 times the number of weeks plus the 25, and the total length of the snake would be L. So hopefully we can see when we're supposed to write it in AX plus BY equals C form compared to when we write it in Y equals MX plus B form. Alright, last one, a nice little math story. You have $6 to spend on apples and bananas, my 2 favorite fruits. Bananas cost 60 cents a pound and apples cost $1.50 a pound. And that's good. My Honeycrisps are a little more expensive than that, but I love them. So it asks you to write an equation to find the pounds of apples and bananas you can buy using A for apples, B for bananas. Now in this, it says you're given a total of $6, right? You're given a rate per pound for bananas and a rate per pound for apples. So this is where standard form is appropriate because you have 2 rates in a total. So let's use standard form. A is for apples. And apples, we said, cost $1.50 a pound. So I would write 1.5 times the number of pounds of apples. And I dropped it to 0 because we don't really need it right now. Plus, bananas are 60 cents a pound. So I'm going to drop that other 0 again because I don't really need it. If you want to write it, have at it. Times the number of pounds of bananas. And I have $6 total. So we have our rates for apples, our rates for bananas, our $6 total. Now letter B says, find the intercepts. The easiest way to do that, if I'm looking for the B, okay, or the y-intercept, I'm going to plug in 0 for A. I can cover that right up, and it would be 6/10 times B equals 6. If I want to know the number of pounds of apples, or the apple-intercept, the x-intercept, I would just cover up the B, plug in 0 for that B, and it's going to be 1.5 times pounds of apples equals 6. So we're just going to solve this. Divide by 6/10, and B equals, do you remember what 6 divided by 6/10 is? it's 10. And then 1.5, I got to divide 6 by 1.5. So 6 divided by 1.5 would be 4. All right. Without even using a calculator. You're allowed to have one out. It's okay. I'm not going to take them away, but we should be fine. All right, now we used A for apples, and that's kind of in the X spot here. So I'm going to call this apples, and I'll put pounds here, LBS. And over here I'm going to put bananas. That's supposed to be representing the Y, LBS. Now to graph this, you don't need to find a whole bunch of ordered pairs. If we know that our x-intercept, A, is 4, then I'm going to go on the apples and plot 4. And if we know that the intercept for bananas is 10, then on bananas, on that axis, bananas. Sorry, I get that song in my head every time. I'm going to plot it at the 10. Now, all I do is connect the dots. I'm not going to keep going and draw arrows because you can't really have negative pounds of anything. So it would just look like that. Okay, last question. I know, and then we're done. Yippee skippy. It asks you to interpret the intercepts. So what does that mean? Well, the apple intercept, when the apples are 4, what are bananas? 0, right? So the x-intercepts tell me how many pounds of apples I can buy without buying any pounds of bananas, and the bananas tell me how many pounds of bananas I could buy without buying any apples. So for apples, I would just say I can buy 4 pounds without bananas. So if you just decided, forget it, I'm only going to buy apples, you could buy 4 pounds of them. For bananas, B-A-N-A-N-A-S, you could buy 10 pounds without apples. So basically those intercepts just tell us when the other one is 0 what the current one is. That's all they mean. I'll see you tomorrow.